Welcome, everyone. Over 13.8 billion years ago, everything that exists, or will exist, erupted into being from an incredibly tiny point, so small it could fit within a single dot of a sentence. But here's the part that's truly astonishing. We're about to take you to the impossible place before that event, a realm where nothing was not simply empty space, where time as we know it did not flow, and where even the idea of existence itself starts to fall apart. We'll dive into the concept of quantum foam, filled with fleeting virtual particles, infinite universes crashing into each other, and mathematical realities that make the universe we know seem incredibly small. If you're ready to challenge everything you think you understand about reality, hit that like button and subscribe. Get ready for this journey. Let's start. Imagine the ultimate dividing line, the exact point where the concept of before ends and when begins. Scientists call this moment T0. But that simple term hides the most intense transformation in the history of the cosmos. At this point, the very idea of before loses all meaning because time itself didn't even exist yet. Take a moment to consider that. No ticking clocks, no aging, no unfolding of events. Not darkness waiting for light, but an absolute absence of time. The equations of mathematics collapse in this place, much like a computer trying to divide by zero. Einstein's equations, which normally explain gravity and space-time perfectly, fail here. They spit out infinities and absurd results. It's as though the universe itself has a "do not enter" sign written in the language of physics. But here's where it becomes truly mind-bending. The moment we're discussing isn't just the start of our universe. It's the start of the very framework that allows anything to begin. Before this moment, there was no setting for the cosmic drama to unfold. No dimensions to measure, no space to occupy, no time to flow. It's like trying to explain the color of something that has never been illuminated in a place where light doesn't exist. That's the kind of challenge we face when we ask what existed before the Big Bang. We're using ideas that only make sense after the very event we're trying to comprehend. And yet modern physics points to something deeply significant occurring in this impossible realm. We'll explore quantum mechanics, a field where even perfect emptiness can briefly flicker with energy. These quantum fluctuations happen constantly today. But what if they could happen in absolute nothingness? Could nothing truly be nothing? Or could it have always been a foundation for something? Leading theories suggest that our entire universe began from one of these quantum fluctuations. Instead of disappearing, this fluctuation grew rapidly, far faster than the speed of light, expanding and creating space as it went. Imagine a soap bubble appearing on a perfectly still pond. But in this case, neither the water nor the surface exists. The bubble, however, creates both as it expands. This rapid growth process, known as cosmic inflation, explains why our universe looks so uniform in every direction. It also accounts for the flatness of space. But there's a more puzzling question that remains unanswered. If quantum fluctuations can create one universe from nothing, why wouldn't they keep going? The mathematics behind these fluctuations suggest they wouldn't stop with just one universe. They would keep creating. The surprising truth lies in what happens when we empty a container entirely. Is it truly empty? We now know that even in the most empty places in the universe, like the space between galaxies, energy still buzzes with activity. This isn't some philosophical debate. It's proven science. We thought we could cool something down to absolute zero to remove all energy, but physics told us something different. No matter how much we try, the energy never reaches zero. Even at the coldest possible temperature, quantum fields still vibrate with what scientists call zero-point energy. It's like trying to stop a pot of boiling water. Even if you remove all the heat, tiny bubbles still keep forming. These quantum fields, which fill all space, create what's known as the quantum vacuum. It may seem calm on the surface, but underneath there's constant creation and destruction happening at scales far too small to see. Now, here's the really strange part. These quantum fields can borrow energy from the future. This energy allows them to create pairs of particles that flicker into existence, interact for a brief moment, and then vanish. This happens trillions of times per second everywhere in the universe. The borrowed energy gets paid back so quickly that it seems as though the universe's accounting system never even notices. But the real mystery arises when we try to understand the vacuum in which these quantum fields exist. If our observable universe came from a fluctuation in this vacuum, what was that vacuum sitting in? What energy allowed it to fluctuate in the first place? We're left with the possibility that even deeper layers of nothingness exist. Some scientists suggest that mathematical relationships, rather than matter or energy, might form the foundation beneath everything. If this is true, our universe might not be made of matter or energy at all. Instead, it might be constructed from mathematical patterns complex enough to experience themselves. Quantum mechanics also suggests that consciousness could play a role in shaping reality itself. In the quantum world, particles exist in multiple states at once until they are observed. The moment a conscious being looks at them, the particles collapse into one state. This raises an important question. Could the act of observation by conscious beings collapse all possible realities into the single reality we experience? Could our very awareness shape the universe? These ideas push us toward even more profound possibilities about what came before the Big Bang. What if, before the universe began, the existence of consciousness itself was what allowed reality to take form? In this view, the Big Bang wasn't simply the birth of space, time, and matter. It was the moment when consciousness began to perceive itself, turning the potential of all possible universes into the single one that we know today. But this idea leads to even more questions. If consciousness played a role in creating our universe, then perhaps other forms of consciousness could create entirely different kinds of universes. Alien consciousness, for example, might generate a reality very different from our own. In fact, this could explain why the universe seems so finely tuned for life. It may not be a coincidence that our particular form of consciousness can arise in this specific universe. It may be that our conscious observation played a part in tuning the constants of physics to allow for our existence. These ideas also bring us to the concept of a multiverse, an infinite number of parallel universes, each with its own set of physical laws and constants. If quantum fluctuations can create one universe from nothing, why couldn't they create many? In this view, the universe we see is just one bubble in a much larger cosmic bath, constantly producing new universes, each with its own unique properties. Some of these universes might be almost identical to ours, while others might have completely different laws of physics. The multiverse theory offers a surprising answer to the question of what came before the Big Bang. Perhaps our universe wasn't the first universe at all. Maybe it was simply the most recent one, formed from the remains of a previous universe that collapsed and rebirthed itself. In this way, the Big Bang would not represent the start of everything, but just the latest chapter in an ongoing cycle of birth, death, and rebirth. When we think of empty space, we usually imagine it as a void, a nothingness that contains nothing at all. But physics tells us something completely different. Even in the emptiest regions of space, like the vast gaps between galaxies, space is alive with invisible energy. This phenomenon is called the quantum vacuum, and it's anything but empty. Scientists have discovered that even when space is as close to empty as possible, energy remains. It's a kind of baseline energy that permeates all of space. Even when we try to cool things down to absolute zero, this energy doesn't go away. Quantum fields, which fill every inch of space, continue to vibrate with this zero-point energy. It's a bit like trying to stop a pot of boiling water. No matter how much heat we remove, tiny bubbles will still form. These quantum fields are constantly creating and destroying particles in what appears to be a perfectly balanced process. These particles, known as virtual particles, flicker in and out of existence in the vacuum, borrowing energy from the future, interacting for a brief moment, and then disappearing again. This happens so frequently that it's beyond the reach of our everyday experience. The energy they borrow from the future is repaid so quickly that it's as if the universe itself is balancing an infinite cosmic checkbook, one that we can't see or comprehend. But this creates a profound question. If these quantum fluctuations can create particles and energy from what appears to be nothing, could they have also created the universe itself? If so, could these fluctuations continue to create new universes endlessly, each one forming from nothing? This idea gives rise to the concept of eternal inflation, where the universe never stops expanding and, in fact, continually spawns new bubbles of reality, each with its own laws of physics and potential for life. It's hard to wrap our minds around the possibility that the very fabric of reality is constantly creating new universes. But the math suggests that this is not just a theoretical idea. Some scientists propose that our universe might just be one of many, each universe arising from its own quantum fluctuation, and each one existing in a vast cosmic multiverse. If the universe we observe can come into existence from a quantum fluctuation, why couldn't this process occur in other ways as well? What if each fluctuation, each burst of energy, not only creates a universe like our own, but also opens up entirely new realms of possibility? Some theories suggest that the quantum vacuum isn't just an empty space filled with fluctuating particles. It's a fertile ground for infinite possibilities. With each fluctuation, new universes are created, each with its own set of rules and laws. This brings us to the idea of the multiverse, a theory that suggests that our universe is just one of countless others, all existing side by side but separated by dimensions that are beyond our perception. These universes could differ in ways we can't even begin to imagine. Some might have completely different constants of nature. Others might operate under completely different laws of physics. Some universes might be sterile with no chance for life, while others could host forms of life so alien to us that we wouldn't even recognize them as living beings. But the multiverse theory raises a whole new set of questions. If there are infinite universes, what makes ours so special? Why does this particular universe appear to be finely tuned for life? For example, if gravity were just a bit stronger, stars would burn out too quickly for life to evolve. If it were weaker, stars wouldn't form at all. The electromagnetic force, which is responsible for the chemistry that life depends on, has to be just the right strength. If it were slightly stronger or weaker, atoms wouldn't be able to hold together. This extraordinary fine-tuning leads some to ask, is our universe a product of random chance, or does it suggest something more? Could it be that the multiverse itself is structured in such a way that universes that are capable of supporting life are not just rare, but inevitable? And if so, what does that mean for the nature of reality? Are we simply one lucky outcome in an endless sea of universes? Or is there something more profound at play? Some scientists argue that the fine-tuning of our universe is merely a coincidence, a statistical anomaly in an infinite sea of possibilities. Others propose that the very fact that we are here to observe the universe is the reason it seems so perfectly suited for life. This idea is known as the anthropic principle, the idea that the universe must have the properties necessary to support life because we exist to observe it. In this view, we are not witnessing a universe that was created with us in mind, but rather a universe that we are lucky enough to inhabit. But even this doesn't completely solve the mystery. If the multiverse theory is true, then we may not be the only ones asking these questions. Perhaps there are other intelligent civilizations out there in distant universes, pondering the same mysteries of existence and looking up at the stars, trying to understand their place in the vast, infinite cosmos. If we take the idea of the multiverse even further, we begin to wonder whether our universe is just one of many, constantly evolving in its own unique way. What if the processes that create universes aren't limited to just one big bang, but are instead a continuous cycle of creation and destruction? Some theories propose that our universe, like many others, may have been born from a previous one, perhaps a universe that collapsed in on itself, only to expand once again in a new Big Bang. This idea of a cyclic universe challenges everything we thought we knew about the beginning of time. Instead of a one-time event where everything sprang from a singular moment of creation, we may be witnessing an endless cycle of birth and rebirth. Each cycle might be a new version of our universe, beginning with its own Big Bang, expanding and evolving, only to eventually collapse in on itself and start anew. In a cyclic model, the Big Bang isn't the beginning of everything. It's simply the latest restart. But even within this framework, we're left with profound questions. What causes each cycle to begin? What governs the transition from one cycle to the next? Is there something guiding this process, or is it all a matter of chance? If this is true, then the very concept of a beginning becomes blurry. It's possible that time itself doesn't have a clear starting point, only an infinite looping process of expansion, collapse, and rebirth. This also opens up the possibility that each cycle could have slight variations, each universe different from the last, just as small changes accumulate over time to create differences in the nature of life or the evolution of matter. One fascinating aspect of the cyclic universe theory is that it can explain some of the unanswered questions of modern cosmology. For example, it offers a potential answer to the mystery of why the universe is so uniform in temperature and density. The process of cosmic inflation, which is thought to have taken place in the first moments after the Big Bang, could have happened in a way that made the universe appear incredibly smooth and balanced. But just as with the multiverse theory, the cyclic universe raises more questions than it answers. For one, if the universe cycles through countless iterations, what causes each cycle to begin? And how can we account for the complex laws of physics that seem perfectly suited for life, despite the randomness of a constantly repeating cycle? As we dig deeper into the fabric of reality, we begin to consider the role of dark energy in shaping the future of our universe. Dark energy, which makes up about 70% of the universe's total energy density, is a mysterious force that appears to be accelerating the expansion of the universe. What's even more puzzling is that, according to our current understanding, this force should have been constant throughout the history of the cosmos. But recent discoveries suggest that dark energy's strength might be changing. Some scientists speculate that dark energy could be responsible for the ultimate fate of our universe. If its strength increases over time, it could drive the universe's expansion faster and faster, leading to a scenario known as the Big Rip, where galaxies, stars, and even atoms will be torn apart by the accelerating expansion. This could be the ultimate end of everything we know, as the universe's fabric itself is shredded in an unstoppable cosmic event. Other theories suggest that dark energy might not be a constant at all. Instead, it could fluctuate over time, with periods of acceleration and deceleration in the universe's expansion. This theory would open the possibility for future cycles of contraction, similar to the Big Crunch scenario proposed earlier. In this case, the universe would collapse back on itself before being reborn once again in another Big Bang. Despite all these theories, one thing is certain: the future of our universe is still shrouded in mystery. Whether it ends in a big rip, a big crunch, or continues expanding forever in a state of eternal inflation, the true fate of the cosmos remains uncertain. But what we do know is that the forces driving this expansion, dark energy, quantum fluctuations, and the unknown mechanisms behind cosmic inflation, are beyond our current understanding. They point to an incredible, vast, and unpredictable future, one that will shape the destiny of everything that exists. While we are still grappling with the mysteries of dark energy and the multiverse, there's another concept that continues to challenge our understanding of the universe: the holographic principle. This theory suggests that our entire universe as we experience it could be a projection of information stored on a distant, two-dimensional surface. In other words, everything we see, our three-dimensional world, the stars, the galaxies, and even time itself, might be an illusion, a hologram created from information encoded on a flat surface far beyond our perception. This mind-bending theory emerged from research into black holes. When matter falls into a black hole, it seems to disappear from our universe forever. But according to quantum mechanics, information can never truly be destroyed. It must always be conserved, even in black holes. Physicists discovered that the information about the matter swallowed by a black hole isn't lost, but is instead encoded on the surface of the event horizon, the point beyond which nothing can escape. This realization led scientists to wonder if the same principle could apply to the entire universe. If information about the cosmos can be encoded on a two-dimensional surface, It would mean that everything we experience is a projection of this information. Our universe, in this view, is like a three-dimensional movie projected onto a flat surface, an illusion created by a deeper, unseen reality. The holographic principle doesn't just suggest that our universe might be a projection. It also implies that space and time themselves might not be as fundamental as we believe. In this view, what we perceive as the three dimensions of space and one dimension of time might actually be emergent properties, arising from a deeper, more fundamental layer of reality. Space and time, as we know them, could be the result of complex interactions between information at the quantum level. But if our universe is indeed a hologram, it raises even more profound questions. Where is the boundary that holds all this information? What lies beyond it? And if the universe is a projection, what is the source of that projection? Some theories suggest that the information encoding our reality could be stored on the cosmic horizon, the outermost boundary of the observable universe. In this case, everything we know, our planet, our stars, even ourselves, might be encoded on a distant surface, while we experience reality as a three-dimensional projection. This idea doesn't just challenge our understanding of space and time, it also invites us to rethink the nature of consciousness. If our reality is a hologram, then consciousness itself could be a projection of deeper information. The act of observation, as we know it, might be a process of decoding the holographic image of the universe, a process through which we become aware of the underlying structure of reality. In this view, consciousness and reality are intertwined in ways we haven't yet fully understood. Conscious beings, like us, might be the key to unlocking the mysteries of the universe. The very act of observation could be what brings the holographic projection to life, allowing us to experience time, space, and matter as we perceive them. If consciousness is truly fundamental to the creation of reality, then it might not just exist within the universe, it might be the force that shapes it, directing the flow of time and the unfolding of events. The relationship between consciousness and the universe brings us to one of the most profound questions in all of cosmology. What came before the Big Bang? We've explored many theories about the origin of the universe, but all of them still leave us with an uncomfortable mystery. What was the state of existence before there was anything? If our universe was born from a fluctuation in a quantum vacuum, what was the vacuum itself sitting in? And what caused that fluctuation? One possibility is that the Big Bang wasn't the true beginning of everything, but simply the moment when our universe came into being from an even deeper layer of reality. Some scientists propose that our universe is the result of a quantum fluctuation in a higher dimensional space. In this view, the Big Bang was not the creation of something from nothing, but the transition from one state of existence to another. The universe, in this sense, could be part of an eternal process of creation and destruction, with each cycle producing a new universe. This idea is closely linked to the concept of the multiverse, where infinite universes exist in parallel, each with its own set of physical laws and constants. In this model, our universe is just one bubble in a vast, infinite sea of universes. Each bubble is created by a quantum fluctuation, and each one goes through its own cycle of birth, expansion, and collapse. The multiverse theory suggests that our universe is just one version of many, constantly evolving in ways we can't fully understand. But what does this mean for the question of what came before the Big Bang? If our universe is just one bubble in a larger multiverse, then the question becomes less about the origin of our universe and more about the origin of the multiverse itself. What gave rise to the infinite sea of universes? Could the multiverse have always existed, with universes constantly popping into existence from fluctuations in the quantum vacuum? Alternatively, some theories suggest that the Big Bang was not a one-time event, but part of an ongoing cycle of expansion and collapse. In this view, the universe goes through endless cycles of birth and death, with each cycle representing a new phase of cosmic evolution. The Big Bang would then be the latest in an infinite series of cosmic events, with no true beginning or end. In this scenario, time itself would become cyclical, with no fixed starting point. Instead of a linear timeline with a clear beginning, we would have an eternal process of creation and destruction, with each cycle giving birth to a new universe. The very concept of a before becomes meaningless because time itself is part of an ongoing cycle that never truly began or ended. One of the most mind-bending ideas to emerge from modern physics is the suggestion that the entire universe might be a vast, self-aware entity. This concept, known as panpsychism, proposes that consciousness is not just something that emerges from complex systems, but is a fundamental property of the universe itself. According to this view, consciousness exists in all things, from the smallest particles to the largest cosmic structures. Everything, in some sense, is aware, and the universe itself is a vast, interconnected network of conscious experiences. If consciousness is truly a fundamental property of the universe, then the boundaries between observer and observed begin to blur. We might not be passive observers of a universe that exists independently of us, but active participants in a shared reality that we are co-creating. Every moment of awareness, every act of observation, could be shaping the reality we experience, not just in the quantum world but on a cosmic scale. This idea pushes us to reconsider the relationship between mind and matter. If consciousness and reality are interconnected, then perhaps the universe is not a machine operating according to fixed laws, but a living, evolving system shaped by the thoughts, perceptions, and choices of conscious beings. This perspective challenges our traditional views of science and the cosmos, suggesting that reality is not something that exists independently of us, but is something that we are all, in some way, responsible for creating. And yet, even as we explore these possibilities, we are left with the mystery of what came before the Big Bang. If the universe is a self-aware, ever-evolving entity, then what was its origin? Did it always exist in some form, and we are simply witnesses to its unfolding? Or did it emerge from a deeper layer of reality, one that exists beyond time and space as we understand them? As we continue to explore these questions, we are reminded that the search for understanding is ongoing. The more we learn about the universe, the more questions we uncover. But each new discovery brings us closer to the heart of the mystery of existence itself. Perhaps, in the end, the answers we seek are not simply about the mechanics of the cosmos, but about the nature of consciousness and our place within the vast, interconnected web of reality.